In products using serial buses such as CAN or I2C, it is important to efficiently verify both software and hardware at the same time. Here, we will introduce examples of debugging using serial decode of the oscilloscope by taking CAN as an example. Turn on the serial decode function of CAN. Since it is hardware processed, decoded display with no delay is possible. The protocol is displayed not only in the list but also under the waveform. Click on the list to jump to the signal waveform and double-click to see the details of the protocol. In addition, detailed waveform display is also possible by CAN DBC file. Simultaneous monitoring of actual waveform and protocol enables system verification from both hardware and software. Let's analyze the error of CAN. InfiniiVision constantly monitors CAN errors without dead time. Apparently, there seems to be an error on the CAN bus. Various triggers can be set with CAN protocol. Let's try to catch the error under the condition of all errors. It seems to be multiple kinds of error packets. Let's separate this with zone touch trigger. It is possible to set the condition of intersect or not intersect in the designated area. This zone triggers with not intersect. This zone triggering intersect. This seems to be an error occurring in ABS. For segment memory function, this error packet can be caught for a specified number of times. Let's capture 10 packets. It is captured with timestamp. You may click on the list and see error packets one after another. The ABS error happens every 300 milliseconds. With this as a hint, you can debug further. Do you realize now the efficient evaluation and failure analysis from both sides of software and hardware in the decode and trigger function?